Alrighty then. I think we picked up two more people while we waited. Let's see. Anyway, so good morning, everybody. Bright and early for me. Maybe not so much for the rest of you, but today is day 3 of the SCOC workshop. Again, this is a workshop from the SCOC, the Survey Cadence Optimization Committee. And today the big focus is to get feedback from the community in the science collaborations. As a reminder, as always with the code of conduct, let's just make sure we be kind. If you do have any issues, please report to either Federico Bianco or myself, or you can reach out to your science collaborations code of conduct contact person. Yeah. As a quick reminder, on day 1, we this is I will post the link to these slides in the Slack channel. But we do have links to the slides from day 1. We went through the original, just the overview of the 5.3 simulations. And we talked about the SCOC assessments by science area. So the SCOC review of some high-level metrics. And day 2, we did a lot more sort of detailed evaluation of different aspects. These slides are here. And we can talk about any of those things. Today, the plan is to give the science collaborations time to talk about what they found or looked at or saw in the 5.3 simulations. I did not get a lot of feedback from people about how much time they needed or if these time slots worked. So I suspect there's a good chance that we'll be a little under on the time we need, and we'll have lots of time for discussion. So we shall see. Now I see Eric is here and had some words to pass from the desk group. Yeah. Do we also have AGN and Galaxies here for this morning?
I'm here, but I don't really
Okay.
have much to add.
Yeah, and yes, I imagine. And Galaxies, maybe we did have the SCOC overview from the Galaxies point of view already, so we may or may not have there. Okay, in which case, Eric, do you want to start? I can just hand over sharing to you if you have slides.
Yeah, sure. I'll share here.
And thanks for the link in the
Yeah, if there's a central repository, we can add them in later, but hopefully this way people can follow along in real time if they want on the slides. I hope you're seeing the slides in a slideshow mode now. Great. So this is just a few slides summarizing what we've been able to glean so far in the Dark Energy Science Collaboration from V5.3. As a reminder, the main metrics we pay attention to, although we look at a lot more than this, but these are the most important ones for us, are a Dark Energy Task Force figure of merit that combines weak lensing and large-scale structure. A weak lensing average GRI visits, that really is just how many total visits you get, and that's because the more visits there are, the more you beat down some of the systematics for weak lensing. The third one is the number of type 1a supernovae below a limiting redshift, and this relates to what Philippe Gries works on. The fourth one looks similar, but it's really about strongly lensed supernovae, so that's into the strong lensing science. And the fifth one is about kilonova population counts over 10 years. And there's links here to the GitHub and a paper describing these. A reminder, as I set out to give this quick summary, that not all metrics are included right now. For some simulations, and unfortunately it's all the ones that Lynn recommended we take a look at, the strong lensing metric is a NAN. We don't understand that yet, but I'm sure we'll be able to solve that and get real results on that in the future. And then, as some of you are aware, Philippe Gris has a custom supernova metric that he has to run. The math team has very helpfully coded an approximation for that. And so we're using that at the moment, pending the chance for Philippe to more fully run the full version of the metric. So I guess this was the caveats slide. All right, so we've got some really nice analysis that Michelle Lochner put together that I'm going to present on her behalf. The first plot here is evolution of baseline simulations going all the way back to V2 through V3, V4, V5, and now most relevantly V5.3, with a couple of versions of that, one that goes to an 11-year survey, and then a couple of comparisons. And so, of course, because everything here is referenced to baseline V5.3, all four metrics for that one sit at 0. They have no difference from it. The quantity being plotted is metric minus baseline divided by baseline. So we're seeing percentage changes for other simulations. Most things were better in the recent past. This is no surprise. We're being realistic here with the as-built observatory and what we can do. Interestingly, the static science weak lensing plus LSS figure of merit has much smaller fluctuations across these changes than the time domain metrics. And for us, the bottom line here is that the 10% reduction in on-sky visits hits the time domain metrics by basically 10 to 20% in the direction we would not like to have. It's a pretty robust effect. And I don't think a big surprise. When you take away 10% of the visits, you could expect a 10% loss in things that depend on time domain. I think the ones that are 20% worse, we should look at and think if we can be clever about, because sometimes it's about having expected something and that's what our metric is looking for. And now we're just below that threshold. And so we think all the data is bad. So everything here needs an iteration before we fully understand it. A set of weather simulations. These I don't understand in detail, but the main point is, that they can be used to estimate the uncertainty because any one of these weather realizations could end up happening. And it's still unclear why, on average, these simulations are better than baseline. Maybe Lynn knows, maybe they tend to be more optimistic about the weather, but I wouldn't have thought so. So it might require a little bit of discussion here, probably later and offline. And then the third plot from Michelle is about some of the other simulations released in this set. So there's faster templates. You'll notice that seems to help a bit with the time domain metrics. That's good. There's adding in the DESI U and G band coverage. Now, I want to be clear, we, as a cosmology collaboration, would love to help enable DESI cosmology as well. Where we're at right now is we don't yet have in place the metrics needed to figure out the impact of these changes on the desk science, because this basically shifts things in early years. And most of the metrics we're looking at are 10 years. We need to understand what this does to our cosmology results after year 1, after 4 years. And these particular metrics, things look worse, but again, we need to develop additional metrics that are looking at the impacts after 1 and 4 years. These are the delayed rolling metrics, then extra blue band and DDF for AGN science, and then removing the TOOs, which seems pretty unrealistic. None of those are providing a big help. Everything's going in the wrong direction. But notice that the amplitudes are not huge. So nothing here is too scary. These are down by sort of 5%, even when it looks bad. I've got a few more slides, but if there are burning questions, it's fine to interrupt me as far as I'm concerned.
I wanted to bring up a comment that just about the no TOO was that, and this is what it's that we took them out of the database, but the time that they were involved with, so that's why it looks like it falls and you don't get any gain back. It's just and the reason we took it out is just because of it's kind of like, okay, and what happens if the TO observations weren't exactly like we thought they were? I honestly, I don't know if that's the best way to analyze that, but it's one thing to look at.
Yeah, sure.
Yeah. Actually, if you can go back a second just to the weather, I just want to make a comment about this because I think the weather runs are very useful, but it is also, they're a little bit harder to understand. So in general, the weather runs, what happens is we have this big I think it's 50 years block of weather at this point. maybe 60. And we take the 10 years of the survey and we are simulating those 10 years of the survey at different points in that weather block, basically. So this is the seeing database, because we remember we use this, sorry, not the seeing database. The seeing database also should get shifted. But the thing is it's the cloud coverage database that gets shifted. And so it's like when the observatory is closed and how long it's closed changes depending on which of those years out of the database history you sample. And so that's the little O and the number is like the number of years that were shifted. So 0, in theory, that should be, I believe, the same as our standard baseline because it's a shift of 0. And Peter should confirm on that. The fact that it's not exactly the same makes me actually wonder about that, if that's really true. I don't know if Peter had a comment.
Yeah, I'm not sure why that one's
Yeah.
totally different.
So another thing that happens is as you may have noticed that we have different we have like baseline 5.3.0, baseline 5.3.1, and they are slightly different in that what this means is the strategy overall was the same, but we may have changed something in Ribbon Scheduler. So one of the things we did that is different between 5.3.1 and 5.3.0 is we actually made some of our code run faster because Peter did some profiling and said, oh, like this is not running as fast as it could be, and so changed a few things. In changing, it really should have been the same, and statistically overall it's the same. But the thing about the visit history is if some visits are different, then you can have a little bit more of a knock-on effect. So it's not necessarily that you end up with completely different behavior. It's just you don't end up with exactly the same visit history. And some of these metrics are quite sensitive to the details of what comes up in the visit history. And the kilonova metric is one of those because in the kilonova metric, we're injecting a lot of kilonova like light curves, but only a very small fraction of those are successfully detected. And so when you have small perturbations in the visit history, the metric itself can change a lot. And so this is why in these runs, this is one estimate of the uncertainty, but there are more things that will contribute to uncertainty in the metric number, like the numbers you get out that are harder to capture. So like the weather history is one thing. There's the questions, some of the questions I mentioned at the end of the first session on Thursday, like we don't add, there is some overhead that variability in the visit gap rate. And there is going to be variability in the weather, but there's also going to be, variability in our faults and things like that. And so these weather runs are good because they help give us at least some estimate of uncertainty, but I don't think it captures all of it. And so I think we can look at this and say, okay, this is at least what the uncertainty is probably likely to be, but it also is, there's more to it. And I think one of the things you're seeing here where you look at weather clouds 0 is the fact that that's not exactly the same as the baseline is telling you that it was probably run at a slightly different time and there was some slight difference in Ribbon Scheduler. And essentially, I think this comes out to be that's kind of part of the noise too.
Okay, that makes sense to me.
Yeah, I mean, it's really hard to get a handle on what the actual uncertainty is. And some metrics are really steady, like you said, the static figure of merit, pretty steady, right? And even here, it varies a bit, but not as much. And then other metrics are very sensitive to some of the details of the simulation, and you find more uncertainty. And the kilonova one is definitely one like that. I'm actually not sure quite why the supernova one is as sensitive. but it is a thing. Bill has a question about climate change and so on. I'd be happy to talk about that, but you said you had like maybe a few more slides, so
Yeah,
I
let me
will.
move on just so I don't end up taking all the time. We can certainly come back to that interesting topic. So this is another analysis that Mi Dai, who's on the line, ran using light curve links to get a quick simulation. And it's complementary to Philippe's more involved supernova metric, but also informative. And so across a different set of several different key versions here of the simulations, we're finding a 4 to 17% reduction in the number of type 1a supernovae in V5.3. We of course expect some reduction because, again, this is an estimate for the as-built observatory. We know we're losing 10% of the visits. And there's a larger impact for the more stringent detection criteria. So this comes back to the issue, you know, as you start to get worse than what we've been planning on, are we being too stringent in our criteria, or is that just what it takes and this more, the 15% hit is more realistic? I think that's something we need to hash out and be sure about. Mi, did you want to say anything more about this, what's on screen?
Maybe just a quick clarification. It's like one set of simulation, but applying different like detection criteria. So like with all these different labels, it's like, for example, for more phases, basically we're requiring like more Likert points to be selected in our sample. So that makes like a more like effectively change in the number in the end.
Okay, thank you. All right, so then let me move on to comments that you've seen in a similar format on day one from our official SCOC liaisons, that's Sarb and Rachel, who are both on the line. And I've bold-faced, that's my own commentary, the first bullet here being really important, that the DESC uniformity metrics were not run. These are essential to understand what's going on in V5.3 and beyond. The metrics aren't, as I mentioned earlier, sufficient to assess the DESI sim. We're going to have to add metrics to understand what happens to our photometric redshifts because of this unexpected possible change in the sequencing of the UNG observations. And then for early cosmology, defined here is up to year 4. So I don't mean exactly official early science. These could be important. We have to look at it very carefully. We're expecting to analyze year 1 and probably year 4 as being highly uniform data releases upon which we can do cosmology analysis. Also TOO issue, and then reminder to ensure that the rolling starts only after templates for that region are available. There are some suggestions made by the SCOC liaisons that I want to reiterate here to look at running the simulations with a decreased WFD footprint. In our view, this would be to take areas at high Milky Way extinction and shrink them down a bit to see if we can recover a higher number of visits per area by reducing the area in areas where it's harder to do science. This would, of course, need feedback from galactic science folks as to which regions would be tolerable to lose. And, of course, changing the footprints and decision needs to be made early and impacts the cadence across subsequent years. We need to routinely run those uniformity metrics and the year 1 to year 4 science metrics, some of which we need to update and add. And then there's further work going on led by Matt Becker to explore uniform rolling options. I know that Peter has also looked at this in terms of things we might change. Instead of coming to uniformity at years 4, 7, 10, maybe it should be 5, 8, 10, or 5, 6, or 5, 7, 10. We'll, you know, some small changes are possible in that. And so that's being explored. I have a slide that's just for reference. So I'm not going to go through this, but these are the DESC publications and call responses related to survey strategy, in case anyone wants to track them down. And then just a list of summary of what we learned, particularly from Michelle and Mi's work. The biggest hit for us comes from the loss of 10% on-sky visits. No surprise. It's partially mitigated by moving to an 11-year survey. Definitely helps, but doesn't solve everything for us. Other simulations have smaller effects, 5 to 10% reductions. The faster templates results in more visits, so then we do a little bit better on the time domain. Increasing DDF visits in the bluer band has some impact on the transit metrics, but it wasn't catastrophic. And we should compare with the full supernova WFD and DDF metrics that Philippe can run to make sure. Obtaining extra U and G band visits in the DESI footprint could harm our transit metrics, but we have to figure out how to check for that in intermediate years in a more robust way. And then delaying rolling cadence has an impact on the transit metrics as well, as well as uniformity that we need to cross-check and come up with a perhaps improved uniform rolling scheme, given what we've now learned about the observatory. So that's all I have from DESC. Thanks for listening. Rachel and Sarb, if you want to add anything, please just speak up. Or we can take more general questions or comments.
All right.
Hey, I
Yeah.
have a question for Eric. Thanks, Eric. This is really helpful. When you say that the the possible changing cadence to support DESI could harm transients, do you specifically mean transients in aid of desk science or in generally? And if it's desk science, do you think that desk will attempt to weigh the pluses and minuses of that versus what they might gain from having all those spectra?
All right. Thank you, Bob. There are a few things in there. So the first is that, yes, I mean transient metrics that are relevant to DESC, in particular supernovae. Of course, if we're concerned about harm to those transient metrics, there are other transients of interest to a wide variety of science collaborations that might be affected. So we should look for everybody. We're also needing to look at the uniformity impacts on photometric redshifts, as was mentioned on a previous slide. So that's a non-transient science issue that comes in from sort of getting deeper in some bands but shallower in others than we had anticipated in previous analyses. Obviously, we see benefit from lots of DESI spectra, but the objects being targeted here from that imaging for DESI-2 have not been a central part of the science plan. There is a Lyman break galaxy science component in DESC that would benefit from more Lyman break galaxy spectra down the line. So that is something we would weigh in a trade-off. So I would say yes to that. But I think we have to be careful not to do something too quickly here before we have a chance to develop the metrics and iterate.
Yep. Thanks. That's helpful. And I agree, it's complicated.
Yeah, thanks again, Eric. I did have a question actually about simulating with a smaller footprint. So I know this request is sort of coming from multiple places. One of the things that this does get a little tricky is that we can reduce the area in the wide fast deep and still meet the SOD area requirement because there's the design requirement, which is at 18,000 square degrees, and then there's like a minimum requirement, which is closer to, I should be careful about this because I always confuse it whether it's actually 15 or 17,000, but it's a smaller number, slightly smaller. And so in theory, we can reduce the footprint in wide fast deep. It then leaves a question like, what do we do about the part of the footprint that we just moved out of wide fast deep? Do we still cover that part of the sky with a reduced number of visits, or do we start leaving holes, right? The other question is, so DESC for a long time said that the area that is currently included in the low dust wide fast deep is the minimum area that's possible because it is the low dust part is about 15,000 square degrees, maybe a little bit more, right? So if we reduce by like 10% and do 5% in high dust and 5% in the low dust area, we're starting to go below that threshold, but is that really as like hard cut and dry as it has sometimes sounded in the past? Or is that, well, okay, yeah, if we have 5% less area, we'll still be doing okay? Because I'm not sure we actually have a metric about that, to be honest.
I have a feeling Sarb has a response to this.
Yeah, so Lynn, could you remind me what is the total footprint area? It's like 21 something around there.
Yeah, it's something
Yeah.
like that.
So is that the number that needs to be above 18 in the science requirements, or is it
No, the science requirements number is about the so it's the wide, fast, deep area, which is area that's covered to the other. So there's two numbers that go together. There's an area and number of visits, and the number of visits is a minimum of 750 in this big area, and the area itself is see, I should look it up again, but the design number is 18,000. Just like the design number of visits is like 825, but we're at the minimum, which is 750. And so, the minimum area is also a smaller number.
yeah, so
And
I
I'm going
think
to go look it up while you talk.
okay, yeah, I think that the idea behind this would be so yeah, so that 21 is already is big, and so presumably that there's other stuff there, but yeah, so if I think you're right that the 15 in the low dust region, ideally we wouldn't want to go below that, but that does leave this like sort of 3,000 square degrees that is too dusty for desk extragalactic science, but is getting wide, fast, deep level visit coverage right now. And maybe the galactic folks are like, yes, that's what absolutely that region needs that. But I suspect, because in the actual plane, they get the galactic plane coverage, which is less, right? And it's, redder and, all the other things. So if some of that 3,000 square degrees could shift from wide, fast, deep like coverage to galactic plane like coverage, maybe that would be a win for everybody. Or not, not a win. I mean, it'd be less visits, but it wouldn't be a detriment to, people's science significantly. So those are the kinds of directions we were sort of suggesting to just look at and see if that was, palatable or not.
Yeah, that it does get tricky because, as you know, the footprint took a long time to evolve to where it is. But yeah.
But I think what Sarah just described is a well-defined simulation that can be done, and then everyone's metrics can be run on it, and they can look at it qualitatively and see if it flies.
Like there may be some very important science that needs wide, vast, deep level visits and it still applies to this dusty region. And then, we'd love to hear what that is. And then, okay, this may not work. But I'm not sure what that science case is because presumably for the galactic science, the galactic plane level coverage is already adequate to do galactic science. So that's the issue. Just, people would have to look at it. I totally agree with what Eric just said.
So I think hopefully we have some people to talk about this later. Oh, I see Fed has a hand up too.
Yeah, I think this is a really important point because of the urgency of the decision, which, as we said, if we want to modify the footprint, we should do that sooner so that we don't cover the footprint with something that then becomes obsolete. And the multi-science aspect of it, I think this would be a good task force project. We could set up a task force that certainly you should involve desk folks and Galaxy science collaboration folks and anybody else, representation from any other science collaboration would also obviously be welcome. We could instantiate it and include people from the community and the SCOC and obviously the survey strategy team. Surab.
Yeah, so one thing is I agree if we actually reduce the actual area that LSST points at, then yeah, that's a decision you don't want to waste time pointing at regions that you're not going to actually do later. But if we do it the way I was suggesting, which is change some fraction of the area from wide, fast, deep like cadence to galactic plane like cadence, then the footprint basically still stays the same. So the time to make that decision becomes less urgent because it's just moving visits around more than changing area.
Yeah. Okay. So first of all, I wanted to make a comment. The minimum area required in wide, fast, deep over any kind of wide, fast, deep is 15,000 square degrees. So certainly within the SRD guidelines, we can reduce the amount of area in wide fast deep. If we move it from wide fast deep coverage into galactic plane coverage, you don't get all of those visits back. So instead of like a 5% gain, if you reduce that, you would get it's not as low as half, but you know the number of visits in that area is just under a third, I think. So you would get some, but not all. And also, John had a comment, and you want to make your comment here, but I also don't want to get too, I think this is something we should study, we could have a look at. And also, when we do this, we have to be very careful. Because like I said, deciding the footprint was very hard, and there was a lot of negotiation and work to get to that point. So it is true, reopening the footprint is a tough one. Yeah, and the stellar pops Milky Way local volume group will have to have a look at what happens as well.
We just
But yeah, given the reduced number of visits available.
Yeah, that's the thing. That's a thing I wanted to just point out. You know, we're getting close to that 750, which was like that minimum requirement for wide, fast, deep, right? And you know, I guess what the 11-year survey can help with that. But if it, you know, if we can't count on that, then you know, it is getting, you know, it's getting close to, you know, what a minimum design requirement, right? And so, you know, I think, yeah, I'm not trying to, please, I'm not trying to say like, you know, the galactic science, you know, in any way is you should make more compromises or anything like that. I just, you know, feel like, oh, you know, it's less visits than people are expecting, and you know that's going to be true everywhere. And so, like, you know, just having some simulations to look at the effects, you know, that's I think that's all we are proposing right now.
Yeah. Yeah, and if you remember, as part of the work to come to that footprint, we did expand the low dust coverage for wide fast deep as well. So it's a tricky question how to redo this again. So, all right, great areas for discussion. I do think we should go ahead and look at a task force with, you know, fairly quick turnaround, presumably. Okay, sorry, my agenda disappeared. So, okay, do we have, Roberta, did you want to say something from the AGN? And did we have anybody from Galaxies who wanted to present anything?
So from the AGN side, there's not much else to add to what was mentioned, and I think a lot of what has been discussed is very much along the lines of the conclusions that Eric just presented. So the 10% does affect a lot of the transient or the variability science, and it's unclear that everything would recover with an 11th year. And there hasn't been really much support for the DESI strategy, for adopting the DESI strategy. But one thing that could be interesting to see or to discuss would be if there's any way to find a sort of midpoint between, so if it goes ahead, would there be a possibility of not going as deep in U and G, such that you can, even with a reduced cadence, you can still keep more U and G observations throughout the rest of the survey in those areas. And other than that, the only other thing was just to reiterate what Neil mentioned, that there's a strong interest that particularly the ocean strategy does not change to reaccommodate the survey. And I don't think that's part of the discussion. I don't think it has been part of the discussion, but just to make sure that it doesn't become part of the discussion too.
That's actually a really good point. We haven't discussed it, but it is true that the deep drilling fields in the current simulations are coming in a bit over 7%. This is one of the places where I think it's just there is still a lot of uncertainty. The deep drilling field visits don't tend to get reduced the way that visits over the rest of the survey do. Like if we have bad weather that lasts for a single night, the deep drilling fields will reschedule themselves to the next night. If we have bad weather for several nights in a row, you do lose that time period. So the experience bad weather or faults or other things that reduce the number of visits in the rest of the footprint in a slightly different way. And that's why you see them go up in these new simulations as a fraction of the total. My inclination would be to say we're still uncertain enough that we shouldn't modify it now. But I do think, well, this is something we'll have to keep an eye on and think about how we can modify it in the future, especially if the deep drilling fields start getting further ahead of the rest of the survey. So it would definitely be worth thinking about how do we respond if we see that happening? Like, where do we go to figure out like what's the next thing? Presumably drop, because if we have more visits, we don't have a problem. But if we have fewer visits, that's when we have a problem. So yeah, so understanding what to do there, like if it's drop the cadence on short time scales, drop the cadence like for some weeks or something like that, it would be good to start getting ahead of that problem, I imagine.
Yeah, I would imagine there would be some support for the SD version of the DDF simulations, but I think that starts getting even farther away from the nominal 7%, right? And I guess a lot of these questions will be things that we'll have to look into sort of as well as the survey progresses. But I was wondering, is there a particular expectation of when we should expect sort of new simulations once the first year is underway? So, right, so with the simulation is what we expect, but once we know how the first year is going, I'm guessing we'll be updating things because that will propagate through the rest of the 10 years.
Yeah, actually, I love this question because it would give me a chance to bring up the idea of survey progress reporting, right? Because they are tied together. So during commissioning with the SV survey, we had the website survey-strategy.lsst.io that had periodic updates. During early operations, we did not post updates there for a variety of reasons, and those reasons are not really good reasons anymore. So I do have it on my list to update that website and put in some updates on what we've been doing to date. So, and then as we start the survey, those regular updates will have to start up again. As part of those regular updates, my initial thought was to include not just the visits we have had to date, but also from those visits, like what would we simulate for the next ongoing period. And it may be that only simulating for the next year is useful. It may be that running for the rest of a 10-year simulation is more useful. It's kind of a trade-off because we can post updates there every month or so, but I don't think people would actually really want to have, an updated simulation, an updated 10-year simulation, but I'm not sure people would really necessarily have the bandwidth to take those monthly updates and do much with them. On the other hand, some people might, so it's likely worthwhile for us to do that anyway, because as part of some of our metrics that we want to report, like, oh, given the current pace of the survey, what do we think we'll do at the end of 10 years? We'll have additional, we'll have to run those kind of simulations, and then we'll have the metrics output, and then we might as well make those simulations available to people as well. The other reporting we are currently doing is nightly reporting. So we did this during the SV survey in commissioning, and we quietly continued doing it during early operations, and now we're talking about it more again. This site, let me grab the link for you. So this site is here, I'll put it in the Zoom chat. So we've been working on these daily reports. If you looked at them during the SV survey and you look at them now, you can see that there are some improvements, and we're working on it further. So if you have feedback to give us about these, please go ahead. You can send it to the Sims channel on, that's probably the best place to do it. Sims channel on the LSSTDA Slack. This, at the moment, these just have nightly reports, but Eric Nielsen is working on standing up a daily progress report. So this will be somewhere in between. We made a new simulation of the whole rest of the survey, but instead it will be like, okay, we take the visits we've had till now, and we take our most recent simulation of the rest of the survey, and we just paste them together at the interface. And so then you can have daily updates on where we look like we are compared to the rest of the survey. So that's still a bit of a work in progress. And we're still trying to figure out what's the most useful things to have for people on the sort of handwritten survey strategy website. But yes, we will be able to make those simulations available to people. We wouldn't, in general, for those, have a lot of variations. We might run the weather variations because I think that might be useful, but we would probably just stick to, like, here's the baseline. So there will still be the kinds of, okay, and now what about different survey strategy options that come in a different set, like a coherent set like we're doing now for the V5.3. And at some point, I think we'll have to look and see what is helpful for the community and how we can help people, guide people to, like, what's the most useful version of these simulations for their work. So that's a very good question, and thank you for giving me a chance to talk about that, which we didn't have on the schedule, but it's yeah, that's the plan. We'll have things like this, and I don't know what the most useful timescale is for that yet. And so if you have feedback about that, that's useful to know too.
Well, thank you very much for the answer. And yeah, I don't have anything else to add. I'm guessing with respect to the question you were just saying about when would it be most useful, I'm guessing it shouldn't be too fast because things vary in timescales and average out. And I think, we don't want to sort of panic modes, every now and then. But yeah, finding what the right cadence is might be, it's not as tricky.
Yeah, yes, I agree. It's a little tricky, and you don't want to perturb somebody when we've had a bunch of downtime, but yeah. We should thank you, Roberto. We should open it up to more general discussion because I don't think that we have a report from the Galaxy Science Collaboration. I just remind you from the SEOC analysis the other day, the concern is uniformity. Certainly also the loss of visits and loss of depth, but bringing up the question of uniformity and what we can do about that is important. And I was going to say that Leanne said she was going to file an RFC, that's a request for comments, with Ribbon to see how we could do some kind of uniform COAD and what would be the options around that. Bindu.
Hi. Yeah, Roberto, I think there is a question about the matrices, and I recall that I don't recall that we discussed this in the AGN meeting, did we?
Which, sir?
So
Which
there is
point?
a question from Federica. The question is, are we happy with the matrices? Do we understand? I mean, it's related to like how do we feel about the current matrices?
Okay. Yeah, so that's that. Yeah, we haven't discussed
We
that
haven't
in
discussed that.
detail. I think
Maybe
there's
something.
some questions about the time lag metrics, that there's some things that I don't fully, or that it's hard to understand exactly why they are reacting the way they are to the changes in the metrics. But I think that has been happening for some time now. So yeah, we should discuss this more in detail. And I think it would be interesting to know also about this sort of future updates, because that means that writing metrics is not necessarily something that is finished, but we could be updating metrics and adding more metrics as sort of science interests keep changing.
Thank you.
Yes, also thank you, Roberto. Writing metrics is not finished, and we do hope people will continue writing metrics. So yeah, that's definitely a good comment. But you had your hand up earlier. I think you put it down now though. So
Yes, I was gonna bring up the question of the metrics, so done.
good, good. Okay. Are there other? There was some discussion about the weather, and I'll just recap that. So Phil's question was, with the metrics being better, looking better with the when we were offset by 30 years. So first of all, you have to be careful about which way that offset works, because I think the 030 is actually 30 years backwards, but it's not. Is that right, Peter? The O number is an offset backwards in time, or is it an offset forwards?
Oh, I don't know. I probably
Okay.
forwards. I think we start at the beginning and then shift it forwards.
Yeah. So I think that it's very hard to interpret which way that shift went. And remember that we wrap around in the cloud coverage database if we hit the end. I do think it went forward because I always thought it went backwards. And when I looked at the actual code, it went the other way than I thought it did. So I think, yeah, it goes forward. And Peter's comment was, it's hard to tell from what we have, and the year-to-year variation is just very big. And Eric Nielsen, who's done a lot more work on this and has included a link to some of his analysis, said it's not really obvious from what we have.
Yeah, I followed those comments through. So thanks all for that. I guess when you choose a 10-year chunk to choose to be the fiducial, we didn't necessarily choose. We didn't know which was going to be the median value in the end. So
Yeah, that is true because and we've actually expanded the database since the time when we picked that initial 10-year chunk. So we definitely didn't pick a chunk that was the median overall, but we did pick a chunk where when we set a threshold, it roughly matched the numbers of the numbers of downtime nights due to weather that were coming from, I think it was from Gemini. Now, the time when we did that calibration was already over 10 years ago, because we've been working on this for a while. And so it is also true that when last summer I was trying to compare, do our numbers match Gemini's numbers, it wasn't exactly one-to-one, like a clear and obvious match. So I do think this is something where, as we go forward in the survey, we will just have to look at what we're actually getting on the sky compared to what our records say. And the other thing is that it is also different from observatory to observatory, what kind of weather you actually shut down for, which we saw last, southern winter. We were shutting down under conditions that we won't be shutting down for this next summer, for example. So It's hard to say, and we'll just have to keep looking and checking. There's not an obvious sign that we're wrong at the moment.
Yeah, thank you.
So I didn't get feedback from other groups about wanting to make sure they had time to present. I don't know if anybody contacted you directly, Fed.
Not that I know.
Okay. And
But maybe we
so
can just, renew the invitation if anybody wants to speak on behalf of their science or a science collaboration without slides, just any comments would be very
Yeah.
appreciated by the SCLC.
Well, and I know Kat had slides for the solar system science collaboration, which were scheduled for 10 o'clock. But if you want to go ahead now, Kat, I think this would
Yeah.
be great.
I don't actually have slides. I just have
Okay.
comments to pass along.
Perfect.
Yeah, we kind of had a Google Doc, and I think, Lynn, you've seen the Google Doc of the feedback. So, but mostly, the biggest concern I've heard from the solar system is that they are unsure about these shorter template observations, the 20-second template tier, just because they're not convinced it's been demonstrated that the depth will be comparable to the 30-second exposures, and they are concerned about losing depth during year one if we go to the shorter template tier. And then, just the same assessment that I kind of gave the other day, that if we add that 11th year, that really does help recover a lot of the solar system metrics. So those are kind of the two comments I got. Overall, the baseline looks like the best of the options, given the kind of uncontrolled, the things we can't change, which is the downtime and the actual performance. So Fed, they're concerned about losing depth in the exposures themselves in terms of using them for science. So solar system has figured out how to detect the objects without the templates. I think it's a concern about losing depth during year one, since so many of the observations will be in that template tier.
Yeah, I mean, I think this is a really, it is a valid concern. It's not super obvious. Yeah, I don't know if that's a good thing to keep in mind. We have a long list of concerns in the RFC that's in progress in the project that are mostly around like the technical questions of whether or not we can whether we can sustain the 20-second exposures given various other things that are happening with the observatory. So I think it is a really good question. It's very
and I know that the
the
template tier is supposed to be only when the sky conditions are really good, but then it's also that like 70% of the observations need to be in the template tier during year one. So that would, I think, in my mind, kind of question: are they all 70% going to be under the best conditions? So I think that's just something to keep in mind.
Yeah.
Pat, is there a trade-off in getting the template? Because solar system doesn't necessarily need templates, but the templates still benefit solar system science. So is there a trade-off between getting shorter and therefore less deep exposures in year one, but getting better, more comprehensive coverage and earlier on with the templates? And can solar system sort of weigh the two issues together?
I mean, that's something I can ask the collaboration to think very carefully about. So I will pass that question along. I guess my other comment, and just looking at the feedback I have gotten, I don't think anybody's really looked at the DESI simulations in detail. So I think that's something that will need to be investigated. Especially because, as I said the other day, I don't know that our metrics fully capture that. And then something else I was thinking about, since we talked about it, like I'm not sure what the benefits would be for solar system from some of the data and other things that have been offered in exchange for the cadence changes for DESI. So that's just something to keep in mind, that I'm not sure what could be traded to the SSSC if there are things that hurt the science for solar system for that particular cadence. That's coming from my opinion. We haven't really talked about the DESI stuff in the solar system science collaboration, just because there hasn't been time to look at that in detail. So that last bit is my personal question. But yeah, I will ask them about the trade-off, faster templates versus depth, to think about that in a little more detail. So that's pretty much what I had from solar system.
Yeah, great. Thanks, Kat. If there's no more comments about these in particular, I see Kathy said that John has some results to talk about for the SMWLV science collaboration. Science stars Milky Way local volume. Yeah. I always get the acronym the wrong way around, so
Yeah. Well, this was only for the parallaxes because I'd been looking at them and checking them. So it's not representing all of the countless other things. But I'm sorry, I'm hitting the wrong button.
yeah, no worries. And I was just going to say,
I'm just
I
going to
know
show
you're-
it without
Yeah,
doing the full presenter view. I think hopefully this is fine the way it is.
that looks good.
I interrupted you. I'm sorry. Go ahead.
I was just going to say, and I know there's a lot of diverse science and diverse metrics in both this group and the TVS group. So
Yeah. So anyway, for the parallax issue, why we always brought it up and why it's in some of the requirements and so forth is you do have to be careful how you sample the parallax curve, and maybe that's illustrated on the bottom right of this plot that I have from an earlier version, right? Which is because as the sky becomes available, you want to observe the source, and as it disappears, you want to observe the source, near its transit, and the sort of the data in between is sort of sampling, regions where there's no parallax signal. And then, of course, there's the time when it's up in the daytime, which also has no useful information. So you just have to be a little careful that you're not chasing things that are rising and setting at the beginnings and ends of nights, because that's a way of removing your parallax signal. As it turns out, the version 5.3, it's perfectly good and will produce lots of great science. I was interested in the rolling cadence question, and so on the left sort of shows you sort of how non-uniform rolling cadence is. I chose a different color stretch than the traditional observatory one, which sort of shows you that there'll be like regions of the sky. Of course, they'll vary, depending on, reality, where you really have sampled things pretty well, and so you'll be competitive. It'll be quite a good test, I think, of the parallaxes, of small parallaxes that you've added together. And of course, other parts of the wide, fast, deep footprint you can see are kind of bluish. They're not going to do as well due to the rolling cadence. None of that is a reason to design the survey around. Over 10 years, it all gets averaged out, as you can see here on the right. And so everything looks quite nice. And so the overall thoughts is that version 5.3, like 5.0 and many of the other major releases, has preserved sampling of the parallax curve and the reddish filters. Thank you. DESI has no impact whatsoever on this, right? Because it's not removing IZY observations. Of course, I just put this in, but losing wide, fast, deep area, of course, proportionally loses the number of objects you can measure. On the other hand, as you make the sampling worse, you don't do as well in the parallax, so you don't go as far out. So that's a bit complicated. We can always look at the simulations, but, very likely it's going to be fine. 5.3 compared to 5.0 is sort of 6% worse for the brighter objects where you can use IZY. And for the intrinsically fainter objects, it's sort of 10% worse. On the other hand, 11 years of 5.3 is better than 10 years of 5.0 for this science case. Astrometry would really, really does love doing just an extra year of data and averaging it all together. The deep drilling fields are an example of being on the wrong side of the trade-off of area versus sampling. Of course, they will get wonderful, wonderful astrometry, but it's not a big enough area of the sky to add up to anything. There's not that many things within 100 or 200 parsecs in those particular fields of view. And then just as we put in the Slack earlier, someone should just double check that that 20-second exposures are not somehow a disaster for astrometry due to the astronomical turbulence and so forth. Under the existing metrics, faster templates, especially over 10 years, has no impact whatsoever. There's no problem at all with doing it from that point of view. It's just a question that, traditionally, you try to take longer exposures to average out over this stuff. Remember that it's not necessarily the seeing, it's how well you can measure the angle between two objects an arc minute apart. And so evidently experience is that that's not necessarily the same as having good seeing, right? And so different nights are different ways. But the modern software corrects that very well. And so maybe it's not an issue at all. It's something that perhaps someone should just double check, because if it turns out that you have twice as much uncertainty unexpectedly, then you really would be wiping out the first year of the survey for proper motions and astrometry. But most likely you aren't, so it'll be fine. That's all I had to say, so I will try to stop sharing. It's certainly a narrow science case, but as far as I can tell, everything is great, and we thank the SSCOC for keeping in mind these metrics.
Perfect. Thank you, John. All right. It is entirely possible that nobody else has anything else to share, but I'm not sure. Fed, do you know if anybody was going to present from the TVS collaboration?
I did not hear from anybody.
Okay.
But we should ask Sarah. Sarah, one of the co-chairs, is here.
Oh, okay, great.
I don't have update from TVS members to share today with you. But of course, we will discuss after the conclusion of this meeting more during the TVS regular meetings, and we will have a collection of inputs more after that. And last time, Rachel has highlighted the important influence that the new simulations can have and the impact on TVS science.
Yeah, it's very valid. Our timescale for releasing these simulations and then asking for feedback is not what we would have hoped in general. There are various reasons around that, having to do with how quickly things are evolving with sort of performance of the observatory in general, and then how quickly we would also like to update our survey strategy for the start of the survey. And again, like I said in the very first day, this is primarily an update to v5.0 and not necessarily a very big change in the overall survey strategy. The major changes being the fact that we see how the templates, what the requirements are for the templates, and that it's a little bit more stringent than we were expecting. And so we have also increased the likelihood of being able to acquire those template images by changing the survey strategy somewhat. So yes, it is a very tough time scale to turn around and say, okay, actually everybody give us this feedback, and this is actually why we have the SCOC, so that they can also buffer those decisions and then make these decisions on shorter timescales, working with the Ribbon Observatory, and then still give options for community feedback.
Sorry, I will just like to add that also for transient variable star science collaboration is not so straightforward as far as so many scientific cases and galactic and extragalactic science is involved. So the ideal plan is to meet at least with all the leaders of the subgroups of transient variable stars. And once all the material from the SCOC meeting, which, by the way, this is a question for you. Are the recordings already available? Sorry for the question, maybe you already have the material. This material will be extremely useful for people that cannot join and to discuss further during the general meetings of TVS.
I'm sorry, I'm not sure I quite understood the
recording material from
the recordings from this. Yes. I will have to talk to the NORA Lab because it's the NORA Lab Zoom. So I will have to talk to them to get the recordings. I actually don't know the answer to that. I'm sorry. I should have checked before today, and
I don't know that answer either, but let me add, we post them as a reminder. We traditionally have posted them on the webpage of the meeting as links, and we will do the same, and we will let you know when they're posted, but also keep an eye on the webpage.
Perfect, thank you.
That's right. So I think we should take we sort of had a break scheduled for 9:20. And then we had other presentations or discussion sections for the rest of the afternoon. For the rest of this time. Fed has a hand up. Maybe you have a suggestion.
No, I just wanted to say, as liaison into the informatic and statistics science collaboration, that they will be excited to contribute to the metrics work and the evaluation work. And so to reach out to the ISSC, there's a number of ways in which we have thought we might be doing it. For example, hackathons. Because the timeline is so rapid, it's a bit hard to decide what is the best path to help people get involved with the ISSC folks who are on the technical side. But some of the software that has been developed that falls under the umbrella of Link and ISSC that recently has been made published, like the Links, like a framework for Likert simulations within OpSINs, can be really helpful. So if you have concerns about your metrics, reach out to your liaison in the SCOC, to the chairs of the ISSC, to me, and we can see if the ISSC can help you realize metrics that are more effective to measure the impact of different OpSINs.
Indeed. Yes. My proposal was going to be we take some time now, we have our discussion, and then when we're done, we can be done for today and not worry about the later sessions, since I think we've already covered all the groups who I know will be presenting. Would that be in line with what you would expect to do here, Fed? Because I know you had lined up the schedule for today, so I want to make sure I'm not missing something, but I also think that we've covered all the things we needed to, and we can take our time back. Excuse my dog. All right, so yeah, are there any other questions or things you wanted to discuss about the V5.3 simulations or the start of the survey, or what information you might be able to get back as we go through the survey? Or maybe you have questions about the SCOC process. I have a hand. Vincenzo.
Just a short question, or maybe it was already asked. Are you going to prepare a summary document as after every workshop? describing the changes in the observation schedule?
The
I can
changes
answer that, Lynn.
Yeah, I was going to say you're working on this already.
Yeah, so the SCSC is preparing one of our recommendations for the start of the LSST. So what will be implemented at the start of LSST survey and how it is consistent and inconsistent with previous observation simulations and with 5.3. The spoiler alert is that basically we're going to recommend to start with 5.3, but keep enough flexibility to be able to change details of the survey even during year one as we hear feedback from the community and assessment of the decisions that are being made. So that usually we had produced a draft of the document before the workshop, then had the workshop, and then released the final document. We obviously could not do this because of the fact that as we enter operation, decisions are going to need to be made in a much more rapid flow. But we will have a draft and we will incorporate comments and feedback from this workshop in the draft.
Yep. Thank you very much. So actually, this is very useful, especially when you need to plan for grants, apply for telescope time and whatsoever. So you have a reference of what is the expected observing plan for LSST. So
yeah, and
thank you very
sorry,
much.
I used the word draft in my last sentence. I didn't mean that. We will release the recommendation to the director as we usually do. That definitely will be public, and you should expect it to be public in, very short time, like days, not weeks, or maybe just a couple of weeks.
All right. And maybe we have talked ourselves out about all the upcoming start of the survey. Phil, I don't know if you had any closing comments you wanted to make, or just comments about where we're standing right now as we're about to start. Oh, actually, sorry, I see Keith actually has a hand up, so if you want to defer to him and let him go first, that's good.
Yeah, go ahead, Keith.
Okay, yeah, this is Keith just asking as a scientist, not in any special position. What is the earliest time that the SCOC would consider making a recommendation of an adjustment relative to version 5.3? Does that set an approximate timeline for science collaborations providing input?
So I want to say that as soon as the SCOC has time to ponder an idea and ensure that it's viable and leads to scientific improvements, we would release a recommendation or anyhow start communicating with the director's office that we think that's a good idea and it should be implemented. We don't have a schedule for when the scheduler can be, like how frequently can the scheduler be changed in year one. I don't think we should actually make that schedule because in year one things will change rapidly and I don't think we want to constrain that. Of course, at the same time, everybody should understand that once we get an idea on our under our eyes, then maybe we need to make a simulations and we need to deliberate on a simulation and we need to ensure that everybody has seen the simulation and assessed all the impacts of that idea and that change. So that process itself takes time. So I don't expect that we will be able to make recommendation on time scales of days or weeks. It will more be like a month or two before we can recommend make a change. Anybody on the SCOC that may want to add or
Actually, Fred, can I give a very specific example here? Because I mean, I think you're probably right that that's a more realistic timescale for the SCOC. But I also want to push back that some of these we may actually be looking at trying to do that sooner. Like, say the RFC for 20-second exposures comes back. Okay, yes, we've tested it out. We've actually taken some on-sky data and it all looks okay. So we think we'd like to try this. if the SCOC says that's the change they want to make. What's the soonest you think you might say, yes, go ahead, please flip over to 20-second exposures? And then a second example of, we haven't looked at reducing the footprint, but when do you think you might come back with something that says, yes, actually go ahead and reduce the footprint, if we were going to? And I know those are tough questions. And so I'm just like, what's the ballpark, like, from the people in the SCOC? Personally, I think like the faster templates, if we were able to validate that that was possible, that you could probably switch over to those within a month. And if we were reducing the footprint, that might take more like 2 months. But I don't know.
Right, and I think the key difference is some of those ideas are already something that we're evaluating, and obviously the process will be faster for those. But if it's something new that we have not considered yet, then it needs some physiological time to make sure that it's a safe choice.
Keith, did you have a...
Yeah, so maybe the follow-up to my question then is, should we consider any of the options that have been discussed at this workshop as formal proposals, so to speak?
Are you asking that in terms of like from the project side, they are things that we should go forward in investigating? Is that what you mean?
No, I'm asking from the SCOC perspective, if any of the options that we've discussed this workshop, are they, is it really like a concrete proposal that the SCOC is considering and is prepared to move forward on in terms of a recommendation, right? Like, will there be another juncture for the science collaborations to provide input before that decision is made?
So so the current set of simulations that we have, the recommendation that we make is going to be based obviously on simulations that we have and that we have seen and we had time to evaluate. So baseline 5.3 or something very similar to that is what we are recommending to start the survey with if the survey starts on a short time scales, which we all think it will. As far as time for feedback from the science collaborations, the next official meeting point where we are all in the same room or virtual room and we can present and entertain presentations from the audience and the SCOC is the RCW session, which I think this year is on Tuesday. And in between, every science collaboration and every science collaboration should contact their liaisons and go through their liaisons, and also everybody in the community can communicate with the SCSC directly, me on Slack, etc. If the survey starts in order of days, then we would only entertain simulations, things that we have seen in simulations and that are very close to what we're looking at right now with version 5.3.
I will also say there is obviously some room for short-term variations. So let's say for whatever reason we can only observe in I-band when we go on Sky. We are only going to observe in I-band. That's not going to be a question, right? We're going to observe, and it won't be the strategy that we've seen.
And we don't need an SCOC recommendation for that.
We don't. We absolutely don't. That would be crazy. Where we might need depending on how long we were stuck in that mode, we might need an SCOC recommendation for what to do afterwards. And because that time scale might be quite short, that may be a thing where the SCOC would end up recommending something that maybe didn't manage to get a lot of input from the community. I think there's just like some corner cases here, right? That we haven't run into, we may never run into, but that are there. And so I think the SCOC absolutely should always vet everything through the community as much as possible, but you still have to reserve the right to make a decision when you need to make a decision on a shorter time scale. So
I think one thing to keep in mind when, thinking through these decision-making things, that there is a difference between survey strategy that we want to get right in the long term, which means making good decisions now, but also survey tactics, which is more kind of responding to realities at the observatory. And I think we're going to have to respond tactically as planned on those short timescales with limited input from the SCOC. I think where the SCOC process really helps Ruben out most is in getting good information out to you in the form of simulations, allowing time for considered feedback, and then working it in thoughtfully. So I think we can imagine benefiting from SCOC, rapid feedback during year one, but it feels to me as though most of the benefit is going to come from how to adjust the survey strategy in years 2 and beyond. And so if there are kind of difficult things there about the details of year 1 in order to try and make year 2 and beyond go well, then it's worth bringing them up. Otherwise, we're going to need to be making tactical choices on the fly while the SCOC and the science collaborations think hard about how to make the best of the rest of the survey.
yeah. And if things go smoothly, we don't have to worry about much, but we'll see. Thanks, Phil. It's a good perspective. Meg?
Sorry, I've only been able to join in the last few minutes. I just wanted to raise, Phil was talking about feedback and community feedback and SCOC feedback, is that we also need transparency, and we need time to be able to digest things. One of the reasons I think there's less or lower attendance, or lower at least in terms of solar science collaboration attendance, is that very little wording, and I understand why, about this meeting and getting feedback and getting people to be able to engage, because it's end of semester for many people, 2-week notice of simulations going out, and timing of this workshop. And so I think, as I understand that, there will have to be tactical changes made, right, based on what the observatory needs are. But how is that going to be communicated to the community? Because even this SCOC process, depending on who your liaison or what they're able to say, is how you're getting information. And I think it shouldn't have to rely on one person in the community to be able to tell us what's going on. And so I'm just wondering if that is, again, the survey strategy website, again, using community better, so that because the last update of notes, I don't know if the last few meetings were updated on the SCOC website, or the SCOC community posts, because those things help us understand what's going on. And so I know there will be rapid things that will have to be decided where there won't be time for community input, but finding a way for the observatory to tell us about those things, or what those decisions as they go, would be helpful. And I don't know where that would be in terms of things right now. And so I think that would be really important. Like knowing that nobody knows what the timescale roughly is for templates.
Yeah.
Yes. And I agree on all of those points. And I also think it's really been very difficult over the last early operations phase. And I hope it gets clearer and smoother. My initial thought is that, yes, we will be providing updates on the current survey strategy and progress on surveysstrategy.lssst.io. And we can also, when we have sort of approved changes in the survey strategy, we can update it there. I think that there's another place that we probably need when we're talking about, like, what are the options for survey strategy changes, and that's currently as the SUC and the liaisons and community. And if that's not working well, then we probably need to have some updates in that process. Go ahead, Meg.
I guess just to respond to that, I think also it's that we have a lot of new people. Like the people who've done the cadence are tired and busy, and I can't get them to look at things. And there's a lot of new people who are overwhelmed and don't understand anything. And so I think I want to push on the observatory a little bit that documentation is your job. Not saying just Ewan, but in general. And I think there's a lot of information that's not available in places to get people up to speed to then be able to help understand, to then understand those more detailed documents about things. And I know that this workshop is part of that reason for having it is to help with that. But videos and workshops can't be the only way that this information is available, because that's not long-term sustainability. And so I want to just push that as we go into that, this is the cadence or whatever is the cadence for the start, as quickly as possible, getting that up in different ways on websites and things that people can digest that. Because I think, that helps with these more detailed things or information that's coming out. That's what I'm finding is people are finding it, it's difficult to get new people in to know enough to understand math or understand what a math metric is. And then the people that did are now like, I'm busy and I'm teaching and, my kids are on vacation, so I'm off. So I'm wondering if there's a balance, and that's maybe where the CST can come in and help of like, walking us through those more basic information, plus more basics about how the scheduler works and things like that, to take that off of the liaisons, because I don't think that's their job. I think their job is to help interpret some of those things when you have enough information to have those discussions. But how do we get people in the door to understand, what the mini surveys are, or when can we talk about things for year 2? Because we're talking about DESI, but can we start talking about solar system de-drilling fields? We didn't think that was available to year 2, but DESI seems to be talking to people now. So how do we get those things on that? And maybe that's somewhere the CST could help.
Yeah, thanks, Meg. That's a good suggestion. And I see the problem that you're flagging. We do need to help new people come in and understand the process and the scheduler in order to be able to make good contributions to this discussion. So yeah, thank you. Fed, you had a hand up.
Yeah, to clarify, it is not the job of the liaisons to train people on how to run the metrics. The job of the liaison is to maintain communication between each science collaboration and the SCOC, let the science collaboration know what the SCOC is doing, let the SCOC know what the science collaborations are doing, and help us interpret the metrics of the science collaborations, in addition to bringing their own expertise, their own specific scientific expertise on the table. A question about ways of trying to help people learning, relearning, or remind themselves how to use the maps. Would a hackathon be a good way to do that, where people can be live in person, or would videos be a better option? Would maybe taking sometimes at the RCW, although I don't know that there is enough time to do that on the schedule, but maybe during the unconference be an option to do that. And also, I want to point out that the experts on math are the survey strategy team. So they're like Lynn and Peter and very few other people. And the community science team they're not experts on math. So while they may help in a number of ways, they can't coach people on how to write a math that's outside of the scope of their expertise.
I think we do have documentation on some of this, but I suspect that it's just not very accessible. And that when we did actually make a couple of slightly more accessible slideshows and stuff, and those are probably lost in the seas of Google Drive at this point. And that so one place the CST could perhaps help us is in they have a better process for documentation. And so perhaps what needs to happen here is that we need to lean on them a little bit more for like a better process so that we can keep it up to date a little bit better. It is also true that the overhead of that documentation is a little bit large for our team right now, given that we don't actually have new people coming in and saying we want to write new metrics. And I think we are at a little bit of a point where we need to look at like what we have in our code base, what other people are starting to develop through Link primarily, and figure out how we can join these together, or like how we bridge that gap. Because do you also see a risk that, as you've heard today, there are people who run metrics in their own way, using the outputs that we have, which is totally fine. We certainly want to encourage like people to evaluate survey simulations however they need to. However, if we don't know how to do that and we don't get that contributed, and we did have this framework for trying to accept those contributions, then we can't run them. And so there's I think this is not the thing we've been focusing on in the last year or so, because we've been focusing very much on like getting reporting and monitoring stuff set up, and we've been focusing on getting the scheduler working and working at the summit. And so it's probably just part of our cycle that we need to come and look at community metrics again and see what we need to do to get sort of to the next stage. But yeah, it's a really good question. Fed, you have your hand up.
Yeah, just quickly, perhaps we can run, if people are still paying attention to the Slack channel of this workshop, perhaps we can run a quick poll on what people think would be the most effective way for them to learn, and also help us base the decision on what to do, whether they are video tutorials or just asynchronous pages that show tutorials as written documentation, or if an interaction like a hackathon or at the RCW perhaps could be valuable, or later as soon as we could possibly arrange.
Yeah.
Yeah, I see many people have their hands up, so I want to be very brief. So what we do for Swift is we organize like 2 to 3 hour online training session, because we know every year there will maybe new researchers coming in. For them it's useful, and then we record it and we post it as well. So that way the old videos are there all the time, and we share slides. So I think we find that it's really effective in that way.
Yeah, and to be honest, we do still have our old workshops, and RCW sessions are accessible, and so we need to I think pull those out into a more accessible place, because the problem with posting them on the workshop websites is that they're harder to find, I think. David?
Yeah, I do. I'll apologize first. I can't show up to a Rubin workshop and not bring up that you're leaving something on the table. If you did dynamically controlled exposure times, that would both effectively gain more survey time, improve uniformity. I mean, there are no downsides at all. And people are always asking me, how did DESI get ahead of schedule? Such a big survey.
Yeah.
Like that's absolutely how. I mean, that's
I
easily.
love that. Yeah. Sorry. I shouldn't cut you off. I'm so enthusiastic that you brought it up again, though. We actually did look at this in an early simulation, and the problem we have is that our so there's a couple of problems, but the the problem it basically came down to, we can't, if we make our exposure time longer on average, then we lose the number of epics.
Right, but
And epics are,
you don't do that. You can
but
keep
it's
the
very
exposure
hard to
time the
predict
same.
ahead of time.
Well, you can make exposure shorter as well.
Yes, and we did. But we can't make them too much shorter, because we do have this problem. Like we already have, when we ran these simulations, we set a floor at, I think, 20 seconds for the visit. And as you see today, we may have a problem even at running at 20 seconds much of the time. In our simulations, it was hard to set the set points because you have to have some way to control what is your current exposure time. And it was hard to set them ahead of time when you didn't know what you were going to be getting for the rest of the survey, so that you ended up with the same number of epochs, the same average exposure time. And so it did turn out to be quite difficult. And when we simulated it, we kept turning out with slightly longer exposure times. And so all of the transient metrics were having a little bit of a problem with that. So first of all, it's just kind of hard to predict ahead of time. Maybe we can work around that and be smarter and like continually adjust what those thresholds are so that we're sort of continually resetting so that we have an average exposure time that's about 30 seconds. The problem is we don't necessarily have a lot of window we can work with. It's much easier to make the exposure slightly longer, especially in clouds, than it is to make them shorter, since we can't go much shorter than, well, maybe we can go to 20 seconds, but
Well, or you go to 15
certainly can't
seconds,
go
but-
shorter than 15 seconds, so.
Yeah, I mean, the overheads,
Yeah.
that DESI has approximately the same overheads as a fractional time. So it's 2 minutes out of 15. So it's about the same. And it's just a huge win.
Yeah, and all I can say.
You're never throwing data out effectively. So.
Yeah, and all I can say in here is that we did look at it, and it was very hard to turn into something that we could use on Sky effectively and not make our mean exposure time longer. And yeah, the duty cycle does get to be a bit of a problem. We certainly can't go shorter than 15 seconds. It's not obvious that we can go to 20 seconds. And so, if the SUC direct us to look at this again, we absolutely would. But we did look at it, and it was hard to make actually work.
Oh, I mean, I'll tell you, we're running this now with dark energy camera on a big survey there. It's great. It's so there we're getting a uniform survey. I don't look forward to Rubin data that's non-uniform. Anyway, I think it's the obvious thing on the table here, and it would prove things for everyone, I think.
Meg?
Sort of a related question. There was a question about why the Solar System Science Collaboration is less happy with going to 20-second template generation observations. And one of the sort of related to this is what is the quality that we're going to get? There's some concern that, especially as we go into the winter months in Chile, and the fact that dome venting is not where it should be. Will we have issues? Will there be thermal issues with temperature? Will the seeing that was getting in April be there over the summer, or in the northern summer, rather, in the winter in Chile? And we're concerned that those things are not the same, and that, yes, the schedule is good at scheduling good seeing, but does anyone know what the performance of the facility is, such that is the mirror thermalizing well to the outside temperatures with only 12 louvers that are active? Are there other mitigations, or are all the heating, cooling, whatever, all those systems working at the level that that's not an issue for the next couple months? Because there was bad seeing last year, and some of that must be some of those effects because there was no dome venting at all.
Yeah,
but that's one of our concerns, is that I don't know what the image performance is to know, or anyone I think in the community really knows, to know if we cut to 20 seconds and things are worse, will that will going to 30 help us enough to make, a difference in year 2, rather than cutting to 20 seconds just to try to get template coverage and then finding out that, well, we also got the performance improved and now we're at LSST in year 2. And so now we have templates that are even worse than we expected. I'm wondering how is all this going in together? Because I just kind of noticed over the past, in the last few reports from early operations that the seeing seems to be worse. And I would imagine that is something involving of the worse weather, winter months, normalization. So how is all this going to be disentangled to make that decision about going from 30 seconds to 20 seconds if DM allows it? I don't know if that has already been studied enough that DM is happy with 20-second template observations. I just want to raise that's where our concern's coming from, because we don't hear that information to know how does that all interplay, or just 10 seconds not matter. I don't know.
So I think the crux of this you're saying is like, what if, regardless of the exposure time, because I think that it sounds like the question is, when we get images for templates out of year 1, if the template seeing is worse than what we actually achieve in year 2, is how much of a problem is. I think that's kind of where this ends up, because that part doesn't matter if it's 20-second or 30-second visits, right?
Well, more flux is more flux, right? So we're seeing a little more flux. Does that help you? How much does it help you? I don't know, because I don't know the performance of the focal plane. I have yet to be. There's only a database that's available as of yesterday that shows me what the limiting magnitude was in the past month. So I don't know. And so there's just concern of we're making decisions on a system that is not 100% fair. And if that 20, does those 10 seconds actually matter? I don't know. But there's concern as it might.
Yeah.
Instead of going, well, but we take it templates in good image in good seeing, so we'll get that back and it'll be just as deep. But that's an assuming good condition, right?
Yeah, I think the answer is that the depth of the templates is somewhat secondary to the pixel coverage. And not only the pixel coverage, but that you have a more continuous PSF. So more epics helps them with making the template coad have a nicer PSF that's more continuous over the sky. I believe there's parts of this here that Eric Ballon really is the one who should talk about, but yes, the crux of it is that it's not the depth so much in the template image that's the issue. It's the number of epics and the coverage on the sky, so the pixel coverage, which is why we would say, okay, we could go to slightly smaller depth in each individual image. Now, I will say, I don't think that the creation of the template from the 20-second images is the big stumbling block, and I don't see that data management putting up a complaint about that. I think the big stumbling blocks are going to be whether or not the atmosphere is really stable enough in the 20-second exposure versus a 30-second exposure, whether the AOS systems are happy running with 20-second exposures and at that rate rather than 30-second exposures. And a little bit in U-band, we may not be able to reduce the exposure time anyway because of the read noise. Because the U-band gets read noise limited very, very fast. And so if we reduce the if we are read noise limited, the noise characteristics in the images are different, and apparently that prints through to the templates. So that might be bad. And maybe Keith has something to say here too.
Yeah, there's another issue related to the active optics system, in that right now the time to compute basically the characterization of the wavefront and to provide the corrections, we're right on the cusp of being able to apply those corrections with N+2 latency. because that time is around 30 seconds. And so we have just enough time basically to determine what those corrections are from the wavefront sensors and then apply them to this 2 visits later. If we drop down to 20-second exposures, then we will need substantial improvements in the speed of the AOS wavefront estimation algorithms to be able to achieve that N+2 latency. Otherwise, we're running at N+3, and it just makes the control loop more challenging. There are multiple approaches that we are pursuing to improve that control, but it does add additional complications.
That is also something that the data management system is evaluating in the request for comments.
So can I ask a question on this?
Mhm.
If the survey started in the next 2 months, our template starting with 30 seconds? Because people, like if 5.3 is out, these are decisions that are happening now, right? Some of this is great discussion, but is there a plan to take 5.3 and use that while these decisions are happening? Because it sounds like this is not something that's going to get decided today or next week or in 2 weeks. This may be longer. So is that the decision to go in with what is 5.3 as the survey strategy if the survey started in, say, the next 2 months or 3 months?
But as someone's here, but I just wanted to say that the 20-second AOS stuff would be something we'd have to test on Sky, and that could be done fairly rapidly, I would think. Anyway, Ed has more comments on the philosophy.
Yeah, as a reminder, I cannot speak for the decision because I chair the SCOC, which makes a recommendation. The SCOC plans to recommend that we start with version 5.3, so with the templates at the regular exposure of 30 seconds, and wait for feasibility assessments from the data management team to see if all of these issues that we have discussed about taking 20-second exposures can be resolved. From a scientific perspective, what we have seen is that the majority of the feedback, now I hear the feedback from the SCOC, and this would also be considered. I hadn't heard it before about the exposure of the depth of the individual exposures. All the rest of the feedback that we got was mostly positive. So scientifically, we think there might be a gain, but not to start with it, because we don't have a feasibility study, and to keep an eye on this, and this may be one of the changes that we would implement throughout year 1, potentially.
I think we should add to the RSC the point that some of it might be in 30 seconds and some of it might be in 20 seconds. And if I don't think that makes any difference as far as creating the COAD, but we should make sure we explain that.
Yeah, I think that's on the request for comments. That question was asked in the request for comments already.
Yeah, and that was always going to be the way, right? Because there are many visits already taken with 30-second exposure time. So part of the deal, I think, was always going to be a mixed set of exposures, or at least part of the opportunity.
Right, and in the COADs, aside from the templates, in the data release COADs, we would have those images, those exposures from the templates, and we would have regular exposures, and we wouldn't, obviously, this would not be a viable solution if they couldn't be combined together.
Yeah.
Well, we kind of went straight through the break, which is okay because now we're not going to come back from the break, I think. I think we've covered all of the things that people have questions about. We've accepted all of the feedback that we have so far, and I'm going to leave it up to Fed to say, how. Actually, sorry, I will say for because I know that the liaisons are always open to feedback from the science collaborations, and then they bring this to the SCOC. And and like Fez said, the recommendation is going to be to start the survey with the V5.3 baseline. And hopefully we start very soon. Phil, did you want to cap it off with anything, or Jelko? I see Jelko managed to just.
I could start, and then if Jelko wants to say something as well. I just wanted to say thank you to you all for your patience waiting for the simulations, and then jumping on them when they came out to analyze them. I mean, the SCOC process at Rubin is a real strength, I think, that we have you here committed to helping making the survey strategy work well, providing that critical interface to the science collaborations and the community beyond that, and we've seen over the years that it does work well. I think we need to keep hold of it and keep working to try and continue having it work well. And so we can work on that from our side of the observatory, getting information out there, and trying to allow time for analysis and deliberation. And I think we'll emerge with a better and continually improving survey as a result. So thank you very much. It's been really good to see you all here and contributing to such a good workshop. I will say thanks very much to Fed and Lynn for all their work organizing it. Not easy to pull things off at short notice, but thank you very much. Jelko, did you want to add something?
I wanted to say something, but you said it all, so I have nothing to add. Thank you all.
Yeah, thank you all for coming out, for your patience with the rapid turnaround at this point. And yeah, let's go start a survey, Sam. Hey, I thank you all for your time. We're canceled for the rest of today. No more SCOC workshop today. If you have slides to send to me, I'll add them to the Slack pages and put a copy in the slides for today if you like. Thanks.
Thanks all.
Thank you.